Today's video will discuss several strategies to help us to maintain data integrity in a class. Hello, I'm James Helfrich. One of the great advantages of a class is that it gives the client assurances that the enclosed data is always in a well-formed state. This video will discuss several different strategies to ensure that's the case. Data protection is a component of robustness, where the design of a class can offer assurances that the data contained therein are always in a valid state. This alleviates the client's needs to doubt the state of an object or to provide validation checks. So with his castle, the important assets, the chapel, the king's residence, all the government officials, things like that, are all stored within walls. Now notice that the only way to get in through the walls is through carefully controlled checkpoints, such as the gate in the center. Data protection is much the same way. Now to understand how this works, take a look at this data flow diagram. Here we have an interactor. The user is going to send text to the prompt, and that's going to get stored in the name. And then the accessor is the display where text gets sent back to the user. Now we're going to introduce something called a trust boundary. A trust boundary indicates the boundary of a class. Data within the trust boundary is protected by private access modifiers, and all interactions are funneled through public methods. There are several different components to data protection. First, we have the public data, and then we also have the private data. We have the public mutator and the public accessor, and we have the private mutator and the private accessor. And of course, we're going to have a trust boundary. Now notice that the private mutator, private data, and private accessor are within the trust boundary that are on the edge, whereas the public mutator, the public data, and the public accessor are on the edge. Of course, we're going to have the client. Now the client can send data to the public mutator, which can then send data to the private data. Now the private mutator can also send data to the private data. Now the private data can get sent to the public accessor as well as to the public accessor. The public accessor can send data back to the client, and the client can have direct access to the public data as well. Now to ensure data protection, all public mutators need to perform proper validation, and all public data access must be made private. In other words, we want to ensure that the client can only change private data through a public mutator. Now, there are several things that need to happen to make this work. The first aspect is a default constructor. A default constructor is a method taking no parameters that is guaranteed to be called with the object's creation if no other constructors are called. Now, notice how the default constructor takes no input parameters but does change the attribute. First, best practice, always provide a constructor for a class. And second, always create a default constructor even when the compiler creates one for you by default. And this gives assurance that all the attributes are correctly set. Next, we have a copy constructor. A copy constructor is a special constructor designed to make a copy of the client. Here, the object goes in and the object's data goes into the attributes. Best practice. Assert on the validity of input parameters for the copy constructor to make sure that the object passed in is also in a valid state. And second, always create a copy constructor. The compiler will create one for you if you don't create one explicitly, especially when you pass a parameter by value. By always explicitly creating a copy constructor, we can make sure that it's done correctly every time. A move constructor is like a copy constructor, except the object's member variables are stolen. In other words, the member variables from the client's input object are transferred into the newly created object, and the input object is reverted to the default state. Now notice that the client is going to send the object to the move constructor, and it's going to get back a default object with all the values stolen. And the move constructor will take that original object's data and send it to the attributes. Best practice. Use a move constructor to avoid unnecessary copies, and the input object to a move constructor should return to a valid, though default, state. Next, a conversion constructor. A conversion constructor, also known as a non-default constructor, are any constructors not otherwise classified as default, copy, or move. They are called conversion because they take one data type, the input parameter, and convert it to another, the class itself. So in this case, we have two conversion constructors, one that accepts data 1 and one that accepts data 2, and both those set the attributes in the valid state. So all conversion constructors must validate their input and, perhaps most importantly, call public mutators when possible. And this ensures that we're funneling all the data validation into the same location. And fail gracefully when invalid input is sent. Usually that means that we're going to set the attributes to the default state. Next, mutators. A mutator is any method that alters the object's state. So here we have a mutator that's going to take data in, it's going to send data to the attribute, but we also have a conversion constructor. Now observe how the conversion constructor is going to call the mutator to make sure that all that data validation is done in a single location. Best practice, avoid public member variables, use accessors and mutators instead, and all client-provided input should be validated. And don't forget, accept input data to the most convenient format for the client. In other words, we want to make sure that our class is most useful in the context of the program for which it's built. Therefore, our public interfaces should accept data that's convenient to the client. And finally, an accessor is any method that accesses member variables. This could be a method that serves to return data to the client, or it could be a method that displays data in some format, or it could be a method which makes a decision based on the data. In any case, the accessor is going to access the attributes and give data back to the client in some convenient format. Best practice, accessors should not change class state. In other words, the accessor should be a constant method. And use asserts to validate the state in the accessors. And finally, give client the data that is well-formed and in the most convenient format. You can learn more about data protection strategies in the data protection chapter of the software design textbook.